We're going to talk today about OPC because there's a new OPC coming out called OPC UA, and the odd thing about OPC is it runs in the background because it does data exchange. So the way that people see it is through the HMI, whatever that HMI happens to be. Whoops. Okay, so let's talk for a real quick second about HMIs, because HMIs are the window into the process. We've all been in control rooms like this where the guys, whoops, let me get rid of my little thing here. We've all been in control rooms where people have the video displays out there that have the nice graphics on them. A lot of them have the HMI panels with the push buttons on them, with the soft push buttons on them that they actually do control from. And it's how they supervise. It's where the process data is displayed, and then the historian in the background records data. So when they got to go back and look at it, they can get the recording of it. And it's what is happening now, and it's what has happened is what the historian has shown. And integrators do the work of creating these HMI screens, but there's a whole task behind. It's not just the screens part that they're doing. There's a whole part behind that where they have to get the data into the HMI software system from the field device where OPC operates. And now I got to get my page to work here. There it goes. So what's involved in looking at this action, not the process out in the field, but the process of making an HMI work here. We're not integrators, so we don't ordinarily see it, but there's 4 tasks here, and 3 of them are involved with the OPC end. The first one is building the tag database, and then there's getting the devices to talk to the HMI software. Then there's getting the historian part of it operating, and then there's developing the screens and populating the screens and making the screens work. We're not going to talk about the screens part because that's not OPC, but those other 3 are all part of what OPC is involved with. When I talk about a tag database is really a huge spreadsheet. It has in it all the tag names, the data format, how the data is dealt with at a binary level, the engineering units, scales for both the scaling factor for the data value itself and for the scale where it's used on the historian. Then there's also, usually in today's world, a whole bunch of other things called properties. They're associated properties like alarm values, alarm status, whether a loop is an auto manual or not, that are associated with this main tag. And it can take days or even weeks to build a tag database by hand. Over time, because computers have got more powerful and they have more memory, we've gotten the higher-end PLC devices to export their tag database, or for the development software actually, to export the tag database so that it can be moved from one element to another, like from the development software for the PLC to the HMI software or to an OPC server or an OPC client. Here's an example of a tag database. It's got all the tag names over in this column over here, then the type of what they are, and they got a Modbus address here, and then there's a whole bunch of stuff that we don't see because this is only a partial part of it right here. But each one of these cells up here has to be populated somehow or another. In the worst case, it's populated by hand. Somebody types it in. In the best case, you import the data and it goes into columns and rows and populates itself in that fashion. And the hardest task is when you start with something like Modbus, because this is what you start with. This is the screenshot from the page in the manual, and each data value in one of these cells here has to be transferred to one of the cells over in the tag database. So there's a lot of typing to do to get this information all the way over. And if you've got hundreds or thousands of points, that can really be a whole lot of work. It is truly, I call it grunt work. It is not a glamorous task. It's just a lot of effort to make that happen. The other task that has to be done here is you've got to actually get the devices in the field to talk back and forth to the software. That was really hard when I started in this business 30 years ago. It's gotten a lot easier today. It's usually over Ethernet nowadays. Sometimes it's over RS-45, but there are the different protocols down here. You can read them that have to be dealt with, that regulate how the data flows back and forth. And in the end, it's software drivers that do this task of connecting the software to the field devices. And I liken that to the FedEx logistics manager. He's got to make sure he's got enough trucks to carry the stuff, enough drivers to drive the trucks, and then he's got to schedule it so everything gets to where it needs to be at the right time. So that's what software drivers do at the lowest level. An HMI historian has to be populated with what data has to be in there, how often it's going to get there, what number format it's going to look like. And this is an example right here. All the tags are listed in this window over here, black on white. And then the ones that are surrounded by red are the associated properties for the particular point that people are looking for on there. So there's an internal task of populating this HMI historian database as well as the main database. So now we got some idea of the tasks that have to be done, and the one circled here in red is what the current level of OPC does. It gets devices to talk to the HMI software. This new coming OPC UA is going to do these other three on there, and again we're going to skip the development and the population of screens because that's not involved here. And so we'll look at what OPC has been in the past. We have 20 years of history of running this stuff. It came about in the mid-1990s, 94, 95, 96. It's called OPC DA, stands for data acquisition. It's very widespread through process controls. The people that think they're just using Allen Bradley, for instance, when they buy Allen Bradley's RSView or Factory Talk HMI package, actually that comes bundled with, I don't know whose it is, but it comes bundled with an OPC server. Allen Bradley licensed somebody's OPC server. So the people that just think they're using Allen Bradley PLCs and Allen Bradley HMIs are actually using OPC for the things to talk back and forth together. And again, it's primarily used by systems integrators. And in fact, the OPC Foundation has polled people and discovered that less than 1/4 of the end users know that OPC is in use on their systems because it runs in the background. It's not obvious. It doesn't pop up and say, hi, we're doing this with OPC. The end users just see the end result, which are the HMI operations. They don't see what operates in the background to get all the stuff to talk together and work.
Dan?
Now, one thing, yes?
Is the OPC kind of like the universal translator between two different systems? Is that one way to look at it?
It's a universal translator between an OPC server and an OPC client. So any brand OPC server talks to any brand OPC client. At the very lowest level, you still have to have a driver to get to the final device. But that's actually a good way of describing it. Yes, it's a universal translator between OPC units. Yes. Now, one thing about OPC-DA is it used a Microsoft component called DCOM, so it could only run on Windows products. And that has limited it because you can't run on Linux boxes, which is what the 1 Series XWire 6000 runs. And you can't, cell phones, for instance, you can't run an OPC product on an iPhone because it's not a Windows product. And so OPC UA is going to go away from that, but that's one of the limitations of the current version that we've been running with for 20 years. So in the end, OPC is all about data exchange. You can see, actually you could put OPC in where this DCOM is right here, and it's OPC is helping a client talk to a server and a server talk to a client. It's all about reading and writing data back and forth. So again, they're hidden, they run in the background, and the OPC server part of it actually talks to the digital field device. Now notice in our graphic here, we got a PLC and then we actually have the hardware out in the field. The digital device is generally the PLC part. So the OPC server talks to the PLC, the hardware wires into the I/O part of it. That's the 4-to-20s and the discretes and the RTDs and the thermocouples and all that kind of stuff. That's what they mean by hardware out here. That stuff gets into the PLC deals with it as numbers, then the OPC server comes, talks to it because it has a driver, and then the OPC server talks to the OPC client over here. So the field devices, the digital field devices are PLCs, PACs, HMI panels, and then actually, technically, OPC can talk to something like a UDC controller or UDC or UDA analyzer, although not a lot of people actually go down to that level. They would actually prefer to drive that stuff into a PLC and have it done there, but it can be done. And again, it does not include, OPC does not include talking directly to 4 to 20 milliamp analog field instruments, because the analog is outside of the realm of OPC. So an OPC client is an HMI. Yeah, I just ordinarily think of, when I hear OPC client, I think of an HMI package. And that's stuff like Wonderware or Cytec or RS View, Factory View. Siemens has a package called WinCC, and I forget what GE calls theirs. And then there's probably 200 other ones out there in the marketplace. Nowadays, nobody puts one out there unless it has an OPC client in there, because it's so widespread they just expect that they gotta have it. Now, sometimes it might be bundled or unbundled. In other words, you might have to pay extra to get the OPC client in there, but it's there and it's available for use. OPC DA is this part here where it's just talking to the PLCs in the field, and then the OPC server, when it gets its data, it hands it off to the OPC client. And Joe brought up that good point there, that OPC client, any OPC client can talk to any OPC server and vice versa. That's the universality of OPC and why it's been so successful, because I can have a Schneider PLC, and I can buy the Schneider driver for it from Matricon, and Matricon is an OPC server, can talk to any of the OPC clients out there. It's just that part is all universal, which is, again, why it's so successful. The rules to remember for OPC is pretty simple. It's any OPC server talks to any OPC client. OPC servers can talk to multiple devices. Now, if it's low end down here, if my OPC server is installed on this Windows box here, and it's talking to these devices down here, if it's got to have a different driver for Mitsubishi than it has to have for a Siemens S7. But that's okay. You buy the driver package, you load it on, and it handles that. OPC servers can talk to multiple OPC clients, so the different resources out there can get this information. Generally, OPC clients do not talk to one another. You got to go buy a very special package if you want clients to talk to one another, because in the world of server client stuff, servers talk to clients, clients talk to servers, but they generally don't cross. Servers don't talk to servers, and clients do not talk to clients. So again, it was really successful out there. Lots of people are using it. Many people don't know that they're using it. But what it allowed, what happened in the industry is, before OPC, the people like Wonderware, they would have to do the driver work themselves, and they'd have to hire these guys that worked in cubes and did low-level coding, assembly-level coding to write the drivers. And it was just a waste of their effort to do that, because everybody that wanted to do an HMI had to duplicate that process. What happened with OPC is, now an OPC server vendor, like a Kepware or Matricon, these people, they write the drivers, they're specialists in it, and that's all they do. I mean, these people, they all talk the same language with one another. They all laugh at the same kind of jokes. It really works well to have OPC server people doing exactly what they do, because it makes it work really well. And it released the OPC client people from having to bother with the effort of having to talk to the instrument. All they're going to deal with is saying, hey, I want this data with this tag name, give it to me. Bonk, and it shows up, and it's already in the right format for them to deal with. So the integrator, again, he gets involved in configuring both the OPC server and the OPC client. He's the poor guy that actually has to build the database inside these things that makes it work. Now, OPC UA comes along after 20 years, okay? And OPC UA is the next generation of OPC. A huge thing is it's not dependent on Microsoft's DCOM component. DCOM had security issues. It was hard to configure. When your PC died, if you were looking at the client parts, it was totally unknown by the IT people, except for our John Trush. He knew about it, but nobody else did. So when the PC died, the DCOM had to be reconfigured. Nobody knew how to do it, and you couldn't use it on Linux. And when Honeywell One Wireless came out, they actually were at the leading edge, because they put OPC UA into that WDM gateway, because they knew that was going to be the trend of the future. And UA can exploit something called XML, which is a text-based format for data exchange. And that'll be real handy because people can edit those files, the integrator people, and make it work. The real, and that's sort of like background stuff, the real power of OPC UA is going to be that it's going to make this kind of stuff available to mobile devices, the cell phones and the tablets, so that the window into the process can be your cell phone or your tablet. You'll be able to view what's happening through a little HMI on a cell phone or a tablet, and that's what people want to do because that's the direction everybody's moving. And as again, sort of a background thing for the integrators, OPC UA is going to automate most of the effort in building that tag database. So again, here's our tag database, and it's got all that stuff associated, you know, or all the things that have to go into there. All this stuff is in the world of programming. You have an element, we'll call it just an RTD out there. Well, that RTD is measuring temperature, but it has a whole bunch of properties. It is an RTD. You got to know that's an RTD because that's how it works. But you got to know what its tag name is. You got to know what the engineering units are. You got to know how people want to look at it. The display resolution. Do they want to look at 2 decimal points worth of data, or 3 decimal points worth, or none? And you got to know how you, when you get data from it, are you going to get it on a 1-minute basis? Or are you going to report on exception? Or are you going to do it really fast? All those things together are called properties. That's a really important word, properties, because all those properties are associated with one thing called this tag name, which is an RTD out in the field out there. So for this OPC DA, where we had to enter all the data by hand, in the future, what OPC UA is going to do is it's going to literally auto-populate an OPC client. And that's like literally pouring all this information. You got all these tags with all that property stuff, and it's going to pour it. The server's just going to pour it into the client. And we can actually do that with this XWire 6000 that we got sitting out in the back, in the warehouse back there. You put you got to have an OPC UA client, but when it sees that OPC server out there, UA server out there, it goes, give me all your stuff. And it goes, and it sucks it up, and it's got it all. So that instead of having to populate the database, now the configuration is just picking out which of those literally tens of thousands of pieces of information you're concerned with and which ones you want to see in the HMI and where they got to be seen in the HMI. So the auto-population thing is huge for the people doing this, and it's going to reduce the cost of doing it because it's going to automate it so that people don't have to sit there and type on their keyboards and do it by hand. And this concept of auto-population is not new. It's been around for at least a decade if you work within your own brand name. For instance, with Honeywell Systems people, if they had Planscape and they wanted to migrate to Experion PKS, Honeywell developed an application program that would actually do that for them. It would auto-populate everything they had in Planscape and transfer it over to PKS, so they didn't have to do it by hand. So it's a well-known concept, but what OPC UA is going to do, again, because Joe brought it up, is it's going to universalize this so that it works across vendor lines. So that if you have an OPC server that's talking to a Mitsubishi device and you got to get the data into Experion PKS, that's fine. It'll just still suck it up and throw it in there. Now, I'm going to give you 2 examples here of what OPC UA isn't, because by seeing that, you can see what hopefully OPC UA is going to bring to the party. These are 2 screens. They happen to be TrendView screens, but this is how people view their data. They view their temperatures as whole numbers here, because that's the way we think of it. When you, particularly in that range down there, when you talk about room temperature, you say it's 78 or 76. You don't go it's 77.3 because you don't care about the tenths. Okay, but over here for the differential pressures, they needed out the 3 decimal points because it's critical. This one right here is right on the alarm threshold right here. 0.005 happens to be the alarm. So they look at it in 3 decimal points there. Now we don't have OPC UA here, so watch what happens. This is a screenshot from when I pulled the data up in Internet Explorer, a browser, because it'll export the data to a browser. And I'm interested in 2 points. I want to see one of them that on the other screen read 0.67, and it's the one up on top here. And it shows up as 6.76526E-02, which is engineering or exponential notation where this is raised times 10 to the minus 2 thing, but you literally have to sit down with a pen and pencil and move the decimal points to figure out that it's 0.067. Okay, and when you look at 63 down here, this temperature down here, you got all that other stuff. It's just noise. You know, I mean, it doesn't mean anything. It's noise. It flitters all over the place. You know, the browser sits there and updates once a second, and all these numbers are changing, making it confusing, when in fact the temperature's stable at 63, because all those lower numbers are just all noise down there. So because we didn't have OPC UA, it just got the value, and the value was floating point. And it just says, okay, here's my floating point value, because it's dumb. And you look at numbers in this format, which you have to reinterpret to get them to mean something. Okay? Now, somewhere in that product, display resolution is a property, and it was already defined. It said for those DP numbers out there, I want 3 digits after the decimal. But Internet Explorer in that application couldn't access the property up here. This is a property. It only accessed the value in the engineering units. So it didn't have a clue about what was happening. So it shows you the thing in the full resolution of floating point, which is, for all practical purposes, for the DPs, it's unusable. The people in the plant can't read that kind of thing, okay? Now, what OPC UA is going to bring to the party is it's going to look at this part up here, which is the property, and it's going to display the value the way people want to see it displayed. Okay? Here's another example right here. You got to pick which things you want to look at, okay? And it displays what's available down here in this little thing called showing pens. Okay, there's 6 pens here. But when you pick them, you know, they've already been defined. Number 1 is inlet pressure. Number 2 is inlet temperature. Number 3 is outlet temperature. Number 4 is demand. They all have a name. They have a name that's recognizable. It doesn't say, do you want, you know, it doesn't let me pick inlet temperature and flow rate and total. I got to pick it by number. So I got to go back to some other thing to figure out what 1, 2, 3, 4, 5, and 6 is, because the property called tag name isn't available on this. When OPC UA grabs all these things as properties and pours them from one thing to another, they're going to be available so that you're not going to be at some low level about 1, 2, 3, 4, 5, 6. You're going to see the name so that you know what it is. And it's going to be easier to pick and choose what you need. Therefore, it's going to be easier to use, and then it'll get more widespread use. So how is OPC UA going to manifest itself when it finally gets here? By the way, this cute little graphic over here, this is the wormhole that all the sci-fi people are so into. Right now we have this big gap between industrial data and our mobile apps. Well, a wormhole is going to open up, and it's going to suck things from one end to the other so that we can actually see that. So that's what the graphic's all about there. So the apps, what we're going to get is apps for mobile applications, okay? And you know, we started out on the title page of this as OPC is data transfer to HMIs. And HMIs can be portables. They can be tablets. They can be cell phones. They can be widgets that go on your desktop computer that show you a little window into the process. And that's what's going to happen. That's really when we're going to see this come out there. And it's going to expand through the evolution of the fact that it doesn't rely on DCOM anymore. It's going to use XML as one of its data languages. And it's going to be available on Linux, like the XWire 6000. It's going to reduce the cost of developing this kind of stuff, because when it pours itself back and forth, and when you can actually see the tag name of what it is and all the properties are there, it'll be real easy at this point to develop HMIs. It's going to take away a huge part of the grunt work of systems integrators. It will be considered the backbone of what people call IIoT, which is the Industrial Internet of Things. That's what the IIoT stands for. That's going to be the backbone that carries all this data back and forth and gets it in the right spot at the right time. So you got to ask yourself, why isn't it here now? Well, there's 3 reasons. The first one is software, second one is software, and the third one's software. Okay. The latest version of Wonderware is OPC UA compliant. Which version does Abbott run? Well, they got the 5-year-old version. It's OPC DA. It's not OPC UA. The reason is it costs a lot to upgrade the license. They got probably a 1 million tag license in it. It cost them $1 million to upgrade it, and they haven't done it. Okay? So eventually they're going to do that at their corporate level for their desktop displays and that kind of stuff. But I think we're really going to see it come out is when we get the mobile apps in the smaller desktop apps, which will come out that we're going to load them like we load apps on the iPhone. Oh, let's go to the App Store and get this. We'll hook up and we'll see the data on our cell phones. So hold your breath. It's coming. It will be down there. It will be here eventually. So that covers OPC DA and OPC UA. Any questions? Okay, I am going to flip to the next one here.
Hey, Dan.
Oh, yes. Yep.
Hey, before you do move forward, why is this important at this point in time? Because we have a product coming out from Honeywell called Control Edge, which will be here in the spring. That's going to be one of the early PLCs to have OPC UA on it.